Okay, we're going to hide this. And now we're recording, I believe. All right. So this is section 4-4. And this is called Trig functions of any angle. So up till now, we've just done trig functions of angles on. I'm going to turn the lights off so you can see a little bit. All the lights are up, and you still can't see. And it's those high-tech curtains we got over there. Okay, so trig functions of any angle, not angles. Okay, and so far we've just learned about angles on the unit circle. So we're going to learn about angles with circles, A, that don't have a radius of 1, and B, that are not multiples of pi over 3, pi over 6, pi over 4, and so on. Okay, so if I were to draw a circle with my high-tech tools here, try to draw a circle. Ooh, isn't that amazing? So I could draw a angle in any quadrant I want, okay? And here's some angle theta. And remember, whenever you're talking about theta, you're talking about the angle rotated counterclockwise from the x-axis, okay, and stopping somewhere, okay? And this is the point x comma y. But in some cases, instead of calling this 1, like if this circle doesn't have a radius 1, maybe it has a radius of r, okay? But the same relationship holds that was holding before when we had the unit circle. But instead of being a 1 here, I have an r here. So this would be you're going over in the x direction and up in the y direction. So the sine of theta is what over what? Still is what? Y over, in this case, instead of being 1, it's what? R, okay? So the sine of theta is y over r, okay? Cosecant is just the flip of that. Cosecant of theta is just r over y, okay? And r is always going to be positive, okay? R is always about just to keep your signs and stuff straight. And by sign, I mean SIGN sign, like plus or minus. R is you always call R positive, and x and y could be negative and positive, okay? Cosine of theta is, guess what? What over what? X over r. And therefore, secant of theta, which is the reciprocal of that, is going to be r over x. And the tangent of theta is still the same, y over x. Okay? And its reciprocal function, which is cotangent of theta, is equal to x over y. Okay? And so, and they do say where it's, if x is 0 in any of these cases, r can't ever be 0, but if x is 0 or y is 0, then the function is undefined at that point, okay? But those are your quadrantal angles when x and y would be equal to 0. So sometimes they'll give you a problem like this. Sine of theta equals negative 2/3. This is where I messed up in the last class. Tangent of theta is greater than 0, and they say find the other 5 trig functions. Okay? Functions. You ready to do that? I'm going to take a picture of this and put it on a new page. Watch this. Partial. That didn't work. It's going to work in a second. Oh. New page. edit, paste. There's the thing. So find the other 6 trig functions. So if I have something like this, probably what I want to do is draw a picture. Okay, so I'm going to come over here and I'm going to draw a picture. Okay. Not that kind of picture, a picture of a circle. Okay, so I'm so funny. You want to draw a picture of a circle, okay? And you want to put it like that. And first thing you have to figure out is which quadrant I'm in, okay? So you have to figure out where is sine negative and tangent positive. Who can tell me which quadrant I'm in? Mitch? Yes? 3. How do you know it's 3? You're right.
Well, when you divide a negative by a negative, it's positive.
Right. So tan is positive in 2 places. This means where is tangent positive? Tangent's positive in 2 places. It's positive in quadrant 1, and it's quadrant when both x and y are negative, right? So out of those 2 quadrants, tangent is positive here and here. Out of those 2 quadrants, where is sine negative? In the 3rd quadrant. So your first thing you got to figure out is which quadrant I'm in, right? I'm in quadrant 3. And then you draw a little right triangle and you figure out what the sides are. Well, if sine is negative 2 over 3, that means that this side is 2. It's actually like negative 2, right? Because you're going down. And this hypotenuse is 3. Yeah? How could I find this side right here? This is a right triangle. How could I find that? This side right here. 9 minus, yeah, 9 minus, who said that? Very good, Jack. You're using Pythagorean theorem, right? So what Jack said, I'm looking for x, right? So he said x squared plus negative 2 squared equals 3 squared. And he's a pretty smart kid, so he did that and said 9, 4, x squared plus 4 equals 9. So x is equal to the square root of 5, right? Yeah? And so then I'm going to just draw on my picture, instead of calling this x, I'm going to call this square root of 5. Is that square root of 5 going to be negative or positive? It's negative, right? I mean, it's kind of incorrect to call it a length negative, but I always say this is negative, that's negative. And then you can find all your 6 trig functions. So sine we already got is negative 2 over 3, so I can flip that over to find cosecant. So what's cosecant? Flip that over. Negative 3 over 2. The negative could stay up top. And I'm going to look for cosine theta, which is this over this. So that's negative root of 5 over 3. And I'm going to find its reciprocal, secant of theta, which is negative 3 over the square root of 5. If you'd like, it'd be nice if you rationalize that, but I don't want to get you confused. But I just don't want to, I want to keep it clean. Okay? And then tangent of theta is what? What over what? Y over x. So that's negative 2 over negative root of 5, okay, which is equal to positive 2 over positive root of 5. And then cotangent of theta is equal to root of 5 over 2, right? Root of 5 over 2. Yes? No? Maybe? Okay. Questions about that? So there's 2 places where tangent of theta is equal to 2 over root of 5. One is here, but one is also up here, right? Because there's 2 places where tangent. And so, like if they say find a solution to this equation, tangent of theta is equal to 2 over root of 5, there's actually going to be 2 answers. But we worry about that. One answer is this angle right here, from here to here. And one answer is this angle right here. But we're going to worry about that when we get to the inverse trig functions, not yet. Okay? Are we ready to move on? Okay. Okay then. All right. I'll finish my drawing. I'm a very good artist. Oh, that tells me a story. Do you guys know who? Oh, you can't see my computer. Okay, so moving on. That was my story. I had to pause. And we're going to learn about the next thing. No one knows? Okay, so reference angles. So reference angle. And a lot of times we'll talk about the reference angle. And a reference angle is if I draw in my y-axis and a circle in there, okay, like that, and you were to draw in, like, here's a terminal ray, it's called. Here's a terminal ray. Here's a terminal ray. Here's a terminal ray. If the angle goes from here to here, okay, or the angle goes from here to here, or the angle goes from here to here, or the angle goes from here all the way to here, the reference angle is this thing right here. Let's see if I can do a different color, okay? This angle right here is the reference angle. We'll call it like beta, okay? Beta, beta, beta. The reference angle is the positive angle that theta makes with the x-axis. I'll write that down, okay? So the reference angle is the positive, it's positive, and it's acute angle that, well, we'll just call it theta, makes, that's not how you spell makes with the, I was thinking ahead, x-axis, I was thinking x and I wrote axis, okay? So the reference angle, if this is your angle, if you're in the first quadrant, then theta equals beta, okay? In quadrant 1. Okay? We'll call the reference angle B. They don't always call it B, but we'll call it B. B, and usually they use the Greek letter beta, okay? So if in quadrant 1, theta is equal to B, okay? In quadrant 2, to get B, I would have to take pi and subtract theta is equal to B in quadrant 2. Do you understand why that is? Because if I want to find this angle here, okay, this angle B, I would have to take pi and subtract theta, if this is theta from here to here, and I would get out what that acute angle is right there. Yeah? Okay? Anyone want to figure out a formula for quadrant 3? Who's I? Go ahead, Mitch.
Is it pi plus theta equals
Pi plus, not quite, pi plus theta. So how can I find this angle here in the third quadrant?
theta? Theta minus pi.
Yep, perfect. Who said that? Very good, Francesco. So in this case, if I started here and I go theta and subtract pi, then I'm going to get this right here. You see that? Because it's theta units from here, or whatever theta is. If I take theta from here to here, I subtract pi units, I'm going to get what's left over, which is what I'm looking for, which is that little referencing. So in quadrant 3, it's theta minus, it's theta minus pi is equal to B. And in quadrant 4, it's, yep, so I'm going to go all the way around, and then I'm going to subtract theta to find b. So what would you call that? What? 2 pi minus theta. So in quadrant 4, 2 pi minus theta is equal to b. I never really worry about these formulas. I just kind of do it in my kind of intuitively. But it's nice. Some people like to have a formula for finding things. Okay. So and why would you need to know the reference angle? Because a reference angle is always going to be an angle that's positive, and then you could just figure out like which quadrant it's in and and then you determine the sign of it. So it's just another way of doing something. So find the reference angle for find the reference angle for, I don't know, let's do a tricky one. 11 pi over 4. 11 pi over 4. Anyone tell me what the reference angle is? Where am I if I'm at 11 pi over 4? I'm where? Oh, very good. Okay, because 11 pi over 4, I'm going to start here. I'm going to go around, that's 8 pi's over 4, plus 3 pi over 4 more. Okay, so you're at 3 pi over 4, but you still want this angle here, which I'll call beta. What is that angle? If it's 3 pi over 4 to here, how much more is it to get to pi? If this is 3 pi over 4, what's this angle right here? Pi over 4, okay? So the reference angle is just pi over 4. Did you follow that? Yeah. Well, a couple people did. Because you go around once around the circle, and then you go around 3 pi over 4 more, but really what you're looking for is this positive angle right there, right? And that's going to be pi over 4, because it's 3 pi over 4. So you can think of that as 2 pi, or pi, you would use this formula, pi minus 3 pi over 4 equals beta. This one's kind of tricky because you have to use the periodic C, like you're going around. No? No? Are you confused? Who's confused? You're confused, Sarah? Because I guess for this one, you really can't just plug into this formula, right? Because you can't, because if you did that, you'd get 11 pi over 4 minus 2 pi would give you 11 pi over 4 minus
3 pi over
4. Yeah, give you a negative 1. And that's not really, so you have to think you're going around the unit circle so many times, and then you're going to end up. But the reference angle is it's just the angle that you're making with the positive x-axis. Okay? Let's do one real quick one. Find the reference angle. Find the reference angle for 313 degrees. Really easy. Okay? Remember, you're looking for the angle. So that's why I don't like to use formulas, because people just blindly plug in. So you're looking for this angle right here. What's that angle right there?
Oh, it's 47 degrees.
Yeah, it's 47 degrees. You just go 360 minus 313, and the reference is, that's 47, right? 47 degrees. Easy enough? How about for one more? Find the reference angle for negative, here we go, 13 pi over 8 12. Negative 13 pi over 8. I just made that one up. That's a good one. Think about it, okay? You're going this way. Would I be past here? That's 8 pi over 8, right? 8 pi over 8. This is 4 pi over 8. 8 pi over 8. 12 pi's over 8. 13 pi's over 8 is going to put you somewhere over here. So if this is negative 13 pi's over 8, how many more pi's over 8 is it to get to here? Altogether, how many pi's over 8 are there in a circle? 16 pi over 8. So how many more to get to here? Not 3. Oh yeah, you're right. Yeah. That'd be 3 pi over 8 would be your reference, right? Because you're going third, right? Think of it in pi's over 8. 4 pi over 8, 8 pi over 8, 12 pi over 8. So 13 pi over 8 has to be here. 16 pi over 8 would be all the way around. So if you subtract 16 minus 13, I get 3 pi's over 8. So don't try to convert, because I saw in your quiz, a lot of you guys are like trying to change it into degrees and then change it back, and it just makes your life more confusing. Yes, sir?
Would it be 3 pi over 8 or negative 3 pi?
The reference angle is always positive, so it's 3 pi over 8. Okay? I'm going to give you one tricky one. So then what they'll say is stuff like this. I might use the reference angle to find the cosecant of 11 pi over 4. We already did 11 pi over 4, but that's okay. So if I have 11 pi over 4, I think we already figured out what the reference angle was. What was it?
3 pi over
We're going to go around 8.
pi over 4.
3 pi over 4. So the reference angle is going to be pi over 4 right here, right? Because I'm going to go around 8 pi's over 4, 3 pi over 4 more, so the reference angle is 3 pi over 4. So I'm going to take the cosecant of pi over 4, and is that going to be negative or positive? Is cosecant negative or positive in this quadrant? Sine and cosecant go together, so it's positive. So you just leave this alone. How do I find the cosecant of pi over 4?
4 over pi.
No, You don't take 4 over pi. You take 1 over the sine of pi over 4. Okay? Which is 1 over root of 2 over 2. Which is root of 2 if you simplify. Okay? So that's kind of tricky. If this were like 5 pi over 4, then so say we wanted to find the cosecant of 5 pi over 4. Well, that's equal to negative cosecant of pi over 4. Because if I go 5 pi over 4, the reference angle is still pi over 4, but it's in the third quadrant where cosecant is negative. So I would have to stick a negative sign in front of it. Okay? No? Yeah? It's just another way to do the trigonometry, so you don't have to measure. You still have to know your unit circle, but really all you worry about is angles in the first quadrant, and then you determine if that trig function is negative or positive in that quadrant. Look like you're zoning out. Okay? And this is the last type of problem you're going to see. Oh my. Maybe you should stand up. Stand up! Yes. It's supposed to be good for your brain. That's what they said. I read this in a book. You have to stand up and stretch now. Really? No, you don't want to do that? Just get it over with? Okay, I'll just get it over with. It's like going to the doctor. Okay, give me a shot. I'm ready. All right. So the last one, let theta let theta be an angle in quadrant 3. Such that sine of theta equals -3/4. Find cosine of theta. So we already did a problem kind of like this at the very beginning, but there's another way you can do this using the trig identities, okay? And also paying attention to the reference angle and stuff like that. So find cosine of theta. Remember this, sine squared theta plus cosine squared. It's just another way to do the same thing. So I'm going to plug in sine of theta in here, okay? And so I know that sine of theta is -3/4. So I'm going to go -3/4. I'm going to square it. Plus cosine squared theta equals 1. What's 3/4 squared? 9 plus cosine squared theta equals 1. I'm going to subtract 9/16 from both sides. Okay? Minus 9/16 minus 9/16. So that gives me cosine squared theta is equal to, how many sixteenths is it? 7/16. So cosine theta is equal to the square root of 7/16. Do you know that plus or minus? Okay. Do you know that you could pull a square root of 16 out of there? Okay. But you have to leave the square root of 7 alone. So it's plus or minus the square root of 7 divided by 4. And then it tells you that this is in quadrant 3. So is cosine negative or positive in quadrant 3? Negative. So out of these two answers, you can't take them both. You have to take the negative one. Okay, negative square root of 7/4. And that's your answer. Do you believe me? So you could do that without a calculator. There's another way to do it. You could find the inverse of this, and then you could, but it's still not going to give you the right answer because you're going to be, anyway, I'll be quiet. So that's how you do it. I changed your homework up there. I'm going to stop the video now. I didn't make too many mistakes. That's good. 28 minutes.